All right, here's question number 6. This is area volume question. So you're given two areas here, two curves, f at x and g at x. So they tell you which one is. And then it says, let R be the region bounded by the graphs of f and g from 0 to 2. And it says, write but don't evaluate an integral expression that gives the area for R. So our bounds go from 0 to 2. So we're going to integrate from 0 to 2, and then we're going to go top, subtract bottom. So the top for R is f at x, subtract the bottom, which is g at x, and that's it. Part B. In part B it says let S be the region from 2 to 5, shown in the graph. Now if S is the base of a solid, and this solid at each x is a cross section that is a rectangle, so that's the shape we're going to do a volume with no, and the height is equal to half its base. Find that volume. So the first thing I'm going to do is know for a rectangle the area is base times height. And in the question it says the height is half the base. And then I'm going to simplify this, multiply it together, and then I have an area formula to use for the integration. So I'm going to integrate from 0 to 2. I'm going to use that, which is 1/2 the base squared. I'm also going to recognize that it says not just to set it up, but to find the actual volume. So I want to set it up and then find the volume. So I'm going to go top subtract bottom. So that's g at x subtract 0. So g at x subtract 0 is just g at x, and then that's what I'm going to solve. So I know that g at x is x squared minus 2x, and I have to square it and then times 100. So on the side, that's what I'm going to do. I'm going to square this. So that means I have to have the ability to have the algebra to expand. So I'm going to multiply this together. So we have x to the fourth, negative 2x to the cubed, negative 2x cubed, and positive 4x squared. So I'm going to come back here. That 1/2 can also go in front. It's fine. And then I'm going to write that in, which is x to the fourth minus 4x cubed, combining like terms, plus 4x squared. So that 1/2 can just stay in front, and that can, and it doesn't even need to distribute. It could just be part of the answer in front, and then I'm going to integrate here. So I'm going to add 1 to the exponent and divide. I'm going to add 1 to the exponent and divide. I'm going to add 1 to the exponent and divide, and that goes from 0 to 2. Then I'm going to plug in. So I have 1/2. I'm going to plug in 2 to begin with. Then I'm going to plug in 0, but 0 is going to give me the answer 0, so I don't need to do that. So I'm going to plug in 2 all the way across. And then usually at this point I would subtract and plug in 0, but if I plug in 0, I need to know this, but I do know this, that 0 will give me the answer 0, so I don't need that. And that is the answer for the volume. I don't need to simplify it any further. All right, part C, last part. Write, but don't evaluate, an expression that gives the volume of the solid generated when the region S, as described in part B, is rotated about the line y equals 20. So on the graph, I'm going to go y equals 20. And if I'm rotating this, I need to know, is there a space between 20 and region S? And there is. So that means there's going to be 2 circles. So we're going to start with pi. We're going to integrate. Now it's region S, so it's 2 to 5. And then we have 2 circles, a big radius and a small radius that we're going to set up. Now for the big radius, it's going to be top, subtract the bottom of the area. So that's 20, take away 0. So you can write 20, take away 0, or just 20. The small radius is going to be the top, subtract the top of the area. which is g at x. So we're going to go 20, take away g at x. And there's the setup to find the volume if you rotate around the line y equals 20. And that's it. Mr. G Math over and out. Till next time.